Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Let us see the topic of uninformed search algorithms. Uninformed search is a class of general purpose search algorithm which operates in brute force way. Uninformed search algorithms do not have the additional information about state or search space other than how to traverse the trees, so it is called blind search. Types of uninformed search algorithms: breadth first search, depth first search, deep depth limited search, iterative deeping depth first search, uniform cast search, bidirectional search. Breadth first search. Breadth first search is the most common search strategy for traversing the trees or graph. This algorithm searches breadthwise in a tree or graph, so it is called breadth first search. The breadth first search algorithm starts searching from root node of the tree and expands all the successor node at the current level before moving to nodes of next level. The breadth first search algorithm is an example of a general graph search algorithm. Breadth first search implemented using FIFO-Q data structure. Advantage: breadth first search will provide a solution if any solution exists. If there are more than one solutions for the given problem, then BFS will provide a minimal solution which requires the least number of steps. Disadvantages: it requires lots of memory since each level of trees must be saved into memory to expand the next level. BFS needs lot of time if the solution is far away from the root node. Example: in the below tree structure, we have shown the transverse of the tree using BFS algorithm from the root node S to goal node K. BFS search algorithm transfers in layers, so it will follow the path which is shown by the dotted arrow, and transverse path will be S to A to B, B to C, C to D, D to G, G to H, H to E, E to F, F to I to K. Time complexity. The time complexity of BFS algorithm can be optimized by the number of nodes traversed in BFS until the shallowest node, where the D equal to depth of the shallowest solution and B is the node at every state. T of B equal to 1 plus B square plus B power 3 plus up to B power D. Space complexity. The space complexity of BFS algorithm is given by the memory size of the frontier, which is O into B power D. Completeness. BFS is complete, which means if the shallowest goal node is at some finite depth, then BFS will find the solution. Optimality. BFS is optimal if path cast is a non-decreasing function of the depth first search. Next one is the depth first search. It is the recursive algorithm for traversing a tree or graph data structure. It is called the depth first search because it starts from the root node and follow each path to its greatest depth node before moving to the next path. DFS uses a stack data structure for its implementation. The process of DFS algorithm is similar to the BFS algorithm. Advantages: DFS requires very less memory as it only needs to store the stack of nodes on the path from root node to current node. Disadvantages: there is a possibility that many states keep reoccurring and there is no guarantee of finding the solution. Depth limited search algorithm. A depth limited search algorithm is similar to depth first search with a predetermined limit. Depth limited search can solve the drawback of the infinite path in the depth first search. In this algorithm, the node at the depth limit will treat as it has no successor nodes. Further, depth limited search can be terminated with two conditions of failure. Standard failure value, it indicates that problem does not have any solution. Cutoff failure value, it indicates no solution for the problem within the given depth limit. Advantage, depth limited search is memory efficient. Disadvantage, depth limit search also has a disadvantage of incompleteness. It may not be optimal if the problem has more than one solution.